Howdy, my name is Joshua Ramos. I am a general engineering student in Chemistry 119, and today I'm going to teach you about Lewis dot structures and the octet rule. So you must be wondering, so let's start by asking, what is a Lewis dot structure? Well, it's a way for us to visualize the valence electrons and electron bonds between the different atoms in a compound. For instance, H2O and CCl4 are shown here respectively, shown with as a Lewis dot structure. So if you're new to this, you must be wondering, how do I do this? It looks really complicated. Trust me, it's simple. It's 3 easy steps. First, you count the valence electrons for each element and place dots to symbolize electrons in each atomic symbol. Second, you want to draw lines to distinguish bonds between the unpaired electrons to bond them together because electrons want to be paired together. Third, once the bonds are finished being drawn, you want to better organize the atomic symbols to finish a Lewis structure. Okay, the third step isn't really necessary, but it's better for organization and it looks much nicer, as you'll see with this example. So we have H2O and we want to draw a Lewis dot structure for it. We know hydrogen has 1 valence electron and oxygen has 6, which means there's a total of 8 valence electrons because there's 2 hydrogen atoms. Okay, let's go to start with step 1 by drawing the atomic symbols. We know hydrogen has 1 valence electron, so we'll draw 1 dot, while oxygen has 6, so we'll draw 1, 2, 3, 4, 5, 6 dots. Okay, now we see oxygen has 2 unpaired electrons, while hydrogen each have 1 unpaired. So we're going to draw lines to signal that those electrons are bonded to each other. Here they come. Okay, now with a little magic of step 3, the Lewis dot structure is completed, and you've done your first one, if this is your first one. So congrats. And that is the basic steps of how we engage in a Lewis dot structure. Just a quick reminder, you want to fill valence electrons counterclockwise, only doubling up once there are 4. As you saw when I was filling up the oxygen, it's better for signaling or to better visualize how many unpaired electrons there are, and we'll it's better for, and so you don't randomly double up. As you can see, nitrogen only has 1, oxygen has 2 because there's 6 valence electrons, and sulfur goes in that same, fluorine goes in that same counterclockwise fashion. Okay, so how does this apply to the octet rule? Well, all atoms must have 8 electrons because they want to go to 8 electrons because they want to be like a noble gas, except for hydrogen and helium, right? Helium is a noble gas and only holds 2, and hydrogen is in that same row, which means it only wants to hold 2 electrons. We can see this in the H2O example, right? Hydrogen has 1 bond, which means there's 2 electrons that it's sharing or paired with, while oxygen has a total of 8 electrons, right? The 4 valence and 2 bonds. CS2 also has an example. Carbon has 4 bonds, which is 8 electrons, and sulfur has 4 paired electrons and 2 bonds. Okay, for a couple final tips and tricks, hydrogen will never be the central atom, will never double bond. It only wants an extra electron, which means it only will single bond, which makes it a bad central atom. Halogens will also never be the central atom because they only need 1 electron, which means they will never double bond and means that they'll be a bad central atom. Finally, you want to fill out surrounding elements before double and triple bonding. Let's go back to that CS2 example. So carbon has 4 valence electrons, which means 4 unpaired, and sulfur has 6 valence electrons, which means 2 unpaired. As you can see, because there's 2 for sulfur, you can see the carbon bonding with the sulfur unpaired, resulting in a double bond. Now you know a little bit more about Lewis dot structures and the octet rule.